Hello, pre-calculus class. I hope you are doing well. Um, so last video, that's kind of crazy, right? It's been a very obviously a different semester, but I'm glad that we get to have this semester, even though it was online. So this is a little review for your post test. Again, this review is really great for the post test. So different topics you will see on the post test. Obviously, your composition of functions. So with your numbers, same thing with x, even and odd, finding that algebraically, and behavior, given a graph, and just given an equation. So in this video, I'll probably do 2 questions of each. So with this video, the way I recommend, look at the question, pause it, try it out beforehand before watching the part. I try to make sure you feel comfortable with the content before the actual exam. Okay, so with this here, composition of functions, the very first thing we covered. I think it was that Justin guy who came in and talked to us about composition. But basically, we're going to rewrite that g, the little circle sign, f of -4. That little circle sign means composition. So this is now read as g of f of -4, which is great news for us because we remember function notation, and this is always what we're doing. We're taking a number, finding the output, and then plugging that in to our other equation and find that new output. So we always start on the inside. So f of -4. F of -4 isn't too bad. With this here, plug in -4 every time you see an x in your f of x equation. And the beauty of this question is I haven't done this yet. So you get to see me make any mistakes live. Well, it's not live because it's a YouTube video, but you know what I mean. So this is saying here, f of -4 is equal to -6. So with composition of functions, we start on the inside and then work our way out. So instead of saying f of -4, I'm now going to say g of -6. F of -4 and -6 are equivalent. So that's why I'm able to replace it. And now becomes just like the first one. But instead, this time we'll use our g of x equation. -1 times -6, just a positive 6. And that's a positive 13. Doesn't really matter how you write it. However, perfect, look at that. Make sure you write it very nicely and box it up. I think there's one more example of this. There is. So same thing, but now this time I have f of g of -3. So it's switch, nothing too crazy there. With composition of functions, you always want to start on the inside. So my inside here will be g of -3. So take your g of x equation and plug in -3 every time you see an x. Again, probably won't edit this video, so you'll see me work these out real time. Yeah, that should be -5. So not -5, I put -3 for some reason, that's awkward. Should be -5. 18 minus 15 is 3. 3 minus 8 is -5, not -3. Again, I'm not editing this video. Not going to bother with it. Perfect. So with this here now, we saw that f of g of -3 can be the same thing as f of -5. We evaluated g of -3, and we saw that it ended up becoming -5. And so when finding f of -5, very similar, except that now we use our f of x function. So -4 times -5 is 20. If you didn't know, 20 plus 7 is 27. And so please make sure to write your final answer, box it up nicely. And that is invading on the personal space, but it's good enough. Composition functions will be on your post test. something very similar to this. Now, I did not include any of stuff with three functions, solely because we discussed that for like 5 minutes in class. We really didn't discuss that too much. But we did discuss composition functions with x. So it's very similar, except that now, and I'm going to move my person up here, except my person, that's me, except that now we're not evaluating at some number. We're just using our functions altogether. So again, that is, oh, that's not good, isn't it? Perfect. This is g of f of x. So we always start on the inside, which is f of x, but we're not really changing f of x whatsoever. So we're just writing f of x again. But it's fine. Because now this is saying it's very similar to how we plugged in any number inside parentheses into our function. We're going to plug in x squared minus x plus 11 into our g of x function. So now, and there's a lot more space over here, so I'll work it out here. So g of x squared minus x plus 11. I should have enough space. We'll make it work. Minus 4. Again, I plugged in x squared minus x plus 11 into my g of x function. With this here, make sure to just distribute that negative. So negative x plus x minus 11 minus 4, negative x squared, my bad. Combining like terms, you see here, we got some constants on the end. Negative x squared plus x minus 15, which will lead us to say, move that little equal sign down, that g of f of x is equal to negative x squared plus x minus 15. Very similar one next is f of x equals x minus 6, and g of x is 3x squared plus 5x minus 5. We need to find g of f of x. So again, nothing too crazy here. F of x in this case is x minus 6, but we're going to plug in x minus 6 every time we see an x. Now, hopefully by now you're comfortable with multiplying binomials. So, for example, multiplying x minus 6. I'm not going to show the work, but just so you know, x minus 6 times x minus 6, it's just a distributive property. Some people use the word FOIL. You saw that kind of falls apart near the latter end of Algebra 2. Some people use the box method. Doesn't really matter what you use, just use something. And so for this example, I won't show all the little nitpicky stuff of multiplying it out. I'll just do it in my head. X squared minus 12x plus 36. With this here, you can go ahead and distribute that 5. You eventually have to do it. You can do it right now if you like. Minus 5. So now with this here, make sure to distribute that 3. 36x. Not going to try that. That's not too bad. That's only 108. I could have figured that out. Not really. And now, you got to be careful to combine like terms, because wouldn't that be mean if on the post test I worked out a bunch of different possibilities of what your answers might be if you mess up on the algebra? That would be cruel if someone did that. Ooh, especially if the teacher did that, where he was very nitpicky about your work, and that if you messed up one step in your process, that's a potential answer. That would be cruel. What wouldn't it be? Hopefully, I'm not that mean. When I say hopefully, I made the post test already. So 3x squared minus 31x plus 73 would be our final answer here. So with composition functions, you'll see something very similar to this on the post test, with just some numbers to evaluate or it's with just x altogether. In this case, it was just x. I showed the two different possibilities. And if you're having trouble with multiplying binomials, please let me know. But for now, we're going to move on. Move you out of the way. Perfect. So we also talked about even and odd functions. So there's different kind of tests for symmetry that we discussed and we talked about. You can view that video if you need that help as well. But for even, if f of negative x is equal to f of x, then that means our function is even. If negative f of x is equal to f of negative x, then that means we have an odd. If we don't meet either criteria, we have a function that is not even nor is it odd. So biggest thing here, notice I had to compute f of negative x. That's needed because I need to know if that's for even, but I also need to know that for odd. So at the end of the day, I need to know this for sure. So that's where we're going to start off with. We'll start off by computing f of negative x. And I included that little thing up there in the top right corner in case you forgot. So this function, f of x equals negative x to the 7th plus 5x cubed minus 5x. Determine if it's even, odd, or neither. So again, we'll start off with perfect, not that. We'll start off with this, f of negative x. Let's check and see if it's even. So if I plug in negative x and I get my original function, we got an even function, okay? So negative x to the 7th plus 5 negative x cubed minus 5 times negative x. A lot of stuff happening here. Think back and remember from the video. You can watch that video back again if you need help. If you have a negative number to an odd power, that number will still be negative. Okay? Again, if you have a negative number to an odd power, that number is still going to be negative. And so this is going to be a negative times negative x to the 7th. Same thing here. A negative to an odd power, which is 3 in this case, will end up being a negative. So negative 5x cubed. And well, negative 5 times negative x, we know that's just positive 5x. So with this here now, we have a negative 1 times a negative x to the 7th. That'll be a positive x to the 7th. 5x cubed plus 5x. So if you compare this one to our original starting function, notice the signs were just opposite. So this is not even. That's unfortunate. Let's check if it's odd. So for odd, if I take out a negative and distribute it to my function, if it turns out to be f of negative x, which is right here, then we got an odd function. If it's not, that means it is neither. I still don't know how to say that word. Cool. Negative f of x. Again, take a negative and make sure to distribute it to all our terms here. So we got x to the 7th minus 5x cubed. I'm liking this. 5x. This is great news, guys, because this is saying, and you can see for yourself, these two are the same. Negative f of x is equal to f of negative x. Great news, because that means I have an odd function. Okay, let's see another one, very similar. Determine whether the function, even, odd, or neither. And we got f of x equals 3x to the 4th minus x. Again, start off with a negative on the inside. So f of negative x, I see how I incorporated that mark that was already there. Negative x to the 4th minus negative x. Make sure that when you're doing this, anything to an even power is going to make it a positive number. For the other slide, it was anything to an odd power is anything to an odd power. If it was negative, it'll still say negative. If it's to an even power, it'll always be positive. So this here now becomes 3x to the fourth, and a negative 1 times negative x is just a positive x. Yikes. So f of negative x does not equal f of x. So that means it's not even. Well, let's check if it's odd. Again, negative f of x. So you take a negative on the outside and make sure to distribute it. Looks like it's not equal to f of negative x as well. So this is not even, nor is it odd. It's neither or neither. That brings us again to something I talked about during class. You can't read that. If our highest degree is even, we're about to talk about end behavior, but don't make that assumption that just because the highest degree is even, that means it's an even function. The last example we just did is a perfect example of that. If I was lazy and didn't want to show my work, I saw, hey, 3x to the fourth. 4 is the biggest number. We're good. We're set. That's an even function. Move on. Well, clearly by doing our work, we saw that it was not an even function. It wasn't even odd as well. It was neither or neither. And so with this here, remember, even functions are symmetrical about the y-axis. Odd functions are symmetrical about the origin. Just because the highest degree is even does not make it, and does not automatically make it an even function. Same thing for odd. So that does tell us, though, about our end behavior. So end behavior was the final thing we covered. This was from the video. I think it was during this part where I fought for my life over a wasp trying to kill me. The degree, that's talking about the highest degree. Leading coefficient, that's the coefficient that's associated with our highest degree. And this is just some examples I pulled up, and did it. Biggest thing here, even degrees. The ends are going in the same directions. Okay? Both ends, left and right end, will go in the same direction. It's our leading coefficient that determines if they're both going up or both going down. As opposed to an odd degree. If our highest degree is an odd number, our directions for our right tail, left tail will go in opposite directions. Now, if you have a positive, that means our right side goes up. If we have a negative, that means the left side is going up. So make sure you know how to do this, graphically speaking, and we'll do algebraically in a second. Notice here, we have this notation. So I have a function, and it says as x is approaching negative infinity. So that's our left tail. F of x is approaching, well, let's see here. We got a graph. As x is approaching negative infinity, so as it keeps going that way, what's happening to our graph? Well, it looks like y is increasing. So I would say here, f of x is approaching infinity. And if you notice, the tails are both going in the same direction. So as x is going to the left, y is still going up. As x is going to the right, y is still going up. You can't really draw an infinity sign. Make sure you know how to do this, even for these type of things. Again, as x is approaching negative infinity. So as x is going to the left, or I guess to the left, what's happening with y? It's decreasing. It's approaching negative infinity. Again, we know it's going to infinity because there's an arrow at the end of our graph. The other end of the graph, as x is approaching infinity, what's happening to our y's? Correct. It's approaching infinity. That's not too bad. So make sure you know how to do this with the graph and also with an equation alone. I don't care about 6 of these terms. I only care about one of them. Remember, I only want to look at the highest degree and from that highest degree, look at the leading coefficient. So in this crazy function here, I don't know what it looks like, find the highest degree. And it happens to be negative 4x to the 6. Okay, so now ask yourself, even degree, that means they both go in the same direction. So whatever my answer is for the first one, better be for the second one as well. Oh, it's a negative leading coefficient. Again, it's a negative 4. That means it's going to go, you're close, it's actually going down. I don't know if you're close or not. I'm assuming you got it correct. Never make assumptions. Again, I only care about the leading coefficient. So the coefficient with the highest degree. So on this next one, find our highest degree. Correct. It's going to be that negative 3x to the 5th. So negative 3 is our leading coefficient. Even though it's not out front, it's still our leading coefficient. So with this here, it's x to the 5th. That 5th is an odd number. That means it's going to go in opposite directions. And that negative controls all of it. So since it's a negative 3, that means the left tail is going to go up and the right tail is going to go down. That's kind of weird on the camera. So that means as x is approaching negative infinity, we're going to go up. For some reason, I'm about to write negative infinity. That would have been wrong. And as x is approaching infinity, we're going to go down. So with end behavior, make sure you know, and again, it's that little chart that we did. Yeah, it's a little chart. Make sure you understand differences between all of them. I think that was the last part. It was. Quick video. If you have any questions about this, if you're still struggling with something, please let me know. If you feel confident on that, I'm excited. That's going to be fun. If you have any questions, please let me know just about anything in general. If not, I will see y'all on Thursday. Adios.